Today we're going to talk about percent composition of a hydrate lab. So what is a hydrate? It's a crystal, an ionic compound that has water stuck in it. It's attached already inside. Now, for instance, salt is an ionic compound, sodium chloride. Barium chloride is also called a salt, okay, because it's an ionic compound. But if you notice, both of those look different than this compound, copper sulfate, pentahydrate. And this pentahydrate means that there is water attached. For every copper sulfate crystal, there are 5 waters. Penta is 5. Now, why does this have water stuck in it? Well, there's spaces between the copper sulfate crystals that allows water to get trapped in there. Sodium chloride does not. Barium chloride does not. And it's just the way it's structured. Okay? Why is red red and green is green? It's because it is. So if you look right here, this is an evaporating dish, and you use an evaporating dish to put crystals into, and you use it so it can evaporate water out of it. It's a nice wide open area and allows water to evaporate out. So we use these copper sulfate crystals. We buy it pre-smashed up like this, right, crushed. It's beautiful right here, isn't it? These beautiful blue crystals. We used to purchase it, but then kids would smash it in a mortar and pestle up here, and actually there's a lot of waste. It would stick on the sides, it would spill on the counter, so we decided to buy it pre-crushed. So if you look at A and B, A is a picture of the copper sulfate crystals as they're being heated. As you can see, there's blue here, but there's also patches of gray. See that right there? And so if you look down here in B, there's almost all gray. It's almost yellowy even if you can look in here. It's like a yellowy green. So how do we heat it? We heated it on a hot plate, right? Okay? This is heating on a Bunsen burner. There's a ring, and there's wire gauze, and there's a Bunsen burner underneath here, and it's heating up. So this top crystal, this grouping up here, is called a hydrate. It is hydrated. Down here it's becoming more and more anhydrous. So what does anhydrous mean? This means not water. And what are we doing to it when we heat it? We're actually taking water and evaporating the water. Okay? So by doing so, we can actually figure out how much water is in there. Let's look at a really fast motion time-lapse photography of these beautiful hydrated copper sulfate crystals. And over this time-lapse, you can see how all the water is just driven out of it. Okay? Very slowly, takes a lot of heating. So if I measure it before and I measure it after, I can actually figure out how much water is in the crystals. And by the way, some of you did this. Whoopsie. Some of you took this and you took water and added it to it. So my anhydrous, right, not water, and if you add water to it right here and pour it in, it actually turned back to a hydrated crystal, and it turned that beautiful blue again. If you notice, there's actually some steam here, okay? So we'll talk about that later, what that means. So if you look, you're going to go ahead and get a lab sheet out, copy off the board what I told you to do as far as a chart. I'll show you what the chart looks like in a minute, if you don't have it in front of you. In the meantime, just listen. Okay, so whenever you cook, because that's what we're doing in Chem Lab, we're cooking. We have something that we heat. We need to always weigh our mass of our dish, okay? So whatever we're cooking in, this is our cooking container. So our cooking container, our evaporating dish, weighs 38.90 grams. Now, what do we put in there? We put copper sulfate in there. We put copper sulfate crystals inside. And now when we put the copper sulfate crystals inside, it weighs 41.39 grams. I want to know just the mass of my hydrate before I heat it. That's what we're looking at right here. So if you look the way I have it set up here, this all I meant for here was to find the difference, because if we actually subtract it this way, we get a negative number. So to get the mass of just these crystals, you take 41.39 grams. That's the mass of my dish, right? My dish, plus the mass of my crystals inside. And I'm going to take my 38.90 grams. That's the mass of just my dish. If I subtract them, I just get the mass of just my crystals. Make sense? And that mass is going to be 2.49 grams. And that's important because that's what we are starting with. We are starting with a mass of 2.49 grams, and we're going to heat it up. Okay, and that's what we did. We put it on a hot plate and water evaporated. You don't actually see the water evaporating, but that's what happened to it. We heated it for 5 minutes. Look at this picture down here. It's the same setup, except I have a ring stand, a Bunsen burner, gauze square, right, with this ceramic right here, on a ring. And we're heating it up, same difference. So you heated it for 5 minutes, and you put it on the counter for 5 minutes, let it cool. If you ever take a very hot evaporating dish and you put it on a balance, that means that you can do two things. Number one, you can ruin my balance, so don't do that. And the second thing is there's hot air around here, right? And it's making all these convection currents and moving around. So it actually can influence the mass of the dish and your contents. So you always want to make sure it's cool. So a good 5 minutes is always a good rule. All right, now, what happened when we heated it? Well, when you heated it for about 5 minutes, the contents of my dish actually changed. They turned from a bluish color to a grayish color with blue. So what did that mean? That meant water was being evaporated, and that gray that was left behind is my anhydrous salt. This is my not water, and this is my with water. Now, how do I know? Inside this gray, there actually might be some water that's hidden. So I need to make sure I don't heat this up once, not even twice, and actually not even 3 times. I need to heat it so the mass of it doesn't change, okay? Which some of you didn't do this lab right, and that's okay. You put your masses in the wrong place, or you didn't heat it long enough, or you didn't cool it long enough, or you kept putting more stuff in. So that's why we're doing this together, so that you can get an accurate write-up and understand the concepts, right? And you got back there in the lab and you worked on stuff, so that's a good thing. Right, so let's look at this for a second. What are we doing in this step? In this part, I'm taking my 40.54, and what is that? That's my dish with my anhydrous salt in it, right? After I heated it, right? Didn't I heat it? Okay, heated it, took the mass. So this is my mass after I heated it. And I'm going to go ahead and subtract just my empty dish. What happens when I subtract my empty dish? Don't I get the mass of just my crystals? Right? The mixture of my hydrated and some of my not hydrated anymore. So what's the mass of my dish? 38.90 grams. That's not going to change. And when I subtract them, what do you get? You get 1.64 grams. So what happened? It weighs 1.64 grams now. What did the mass start out to be? The mass started out, looks like it went too far, 2.49 grams. So it got lighter, didn't it? Why did it get lighter? Why did it go from 2.49 grams to 1.64? Well, what did you do? You heated it, and what happened when you heated it? Water went away, right? Water evaporated. Again, you don't see it, but the water evaporated. So now it's lighter, it's 1.64 grams. Now what happens? Now I'm going to take this dish that has my 1.64 grams in it, and what did it weigh? It weighed 40.54 grams. So I'm going to take my 40.54 gram dish, I'm going to put it back on my hot plate. I'm going to heat it up again. Okay? So that's the part some of you didn't do right, but that's okay. So this is my 40.54. Right, that's my new starting mass. Make sense? Right? I'm putting what I heated up the first time back onto the hot plate. I'm going to heat it for 5 minutes. I'm going to cool it for 5 minutes. Okay, and then what I'm going to do? Put it back on the balance and get the new mass. It should be lighter, shouldn't it? Why should it be lighter? Because I'm taking water and I'm driving it out. I'm evaporating it. So let's go ahead and label this A and label this B. And let's talk about how we get this column right here. Okay, this one right here. How do we get that? Well, if you have your dish and your hydrate in it, and this is my mass before I heat it, right before I heat it, I'm going to take these two, I'm going to take B minus A for this column. I'm going to take my dish with my stuff right here and just my dish and subtract my dish out, and I have just my hydrate, don't I? So that is my 2.49 grams. That's what I started with before I heated. Now, moving over to this column, how am I getting my mass of after I heat it? Right, this is after heating. I've heated it, I put it on the counter, and I let it cool. Well, how do I get rid of my dish? Mathematically, don't I take my dish and subtract it from it? So if we call this column C, how are you going to get this column? You're going to take C minus A. I'm going to take my dish with my anhydrous salt, subtract my dish, and I have just my anhydrous. And when I do that, I take 40.54 minus 38.90, I get 1.64 grams. Pause this if you don't get it, and you can go ahead and go back and wind through and see how I got those two numbers, because I already showed you how I got those two numbers, didn't I? Okay, in these slides back here, I showed you how I got them back here. Okay, I subtracted and showed you. So now what? Now we're ready to heat it again, a second time. So what are you doing in this step? And this is the part where some of you made a mistake, and that's okay. I'm going to take this mass right here. I'm going to put it right here. Why? Aren't I taking the dish that I heated and cooled off and putting it back on the balance? So aren't these two the same? Right? I'm going to take what I ended up with here. I'm going to heat it up a second time. So if you look, whoops, let's go ahead and go back. All right? So then what's this going to be right here? Let me get rid of this highlighter. What's this going to be right here? It's going to be this mass. My 1.64 grams is what I start with. Does that make sense? I'm taking my dish after I heat it the first time, putting it back on and heating it again. So this is my mass that I'm starting with, right? What I ended up in the first step, I'm now starting with. All right, now, what's going to happen? This is what I'm starting with, dish-wise, and this is what I'm starting with mass-wise. Okay, so how do we label this? A, B, and C. And how do we get this column again? We took B minus A, okay, which we already did up top, okay? So if I get this column, what do I do? C minus A. So I've heated it a second time. Look what happens. It went from 40.54 grams to 40.47 grams. It got lighter. Why did it get lighter? Because you heated it up a second time. So how do I get this 1.57 grams? I'm going to go ahead and take this 40.47, that's my new mass of my dish with my lighter salt in it, right? It's anhydrous, there's less water in it. I'm going to subtract just my dish out of it. And when I subtract my dish from my dish and my anhydrous, I get this value right here, 1.57. And that's my new mass. So look what happened. I started off with 2.49. What happened to it? I heated it up. It formed 1.64 grams. Then I started with 1.64 grams. I heated it a second time. Now I have 1.57 grams. Why is it lighter here? Why is it lighter than 1.64 grams? Because you heated it a second time and the water got driven off. So if more water is going away, you're getting closer and closer to getting the water out and making it anhydrous and having just copper sulfate. So how are we going to do this again? We're going to take this mass, put it back on your hot plate, and heat it up again. What's the mass of my dish? Oh, look, it's 38.90 grams, always, right? That's my vessel that I'm heating it in. How do you get this column right here? This is my dish with my hydrate. It's not very hydrated anymore, is it? It's more and more dry than it is wet. So if we call this A and we call this B, don't we take B minus A? Okay, we get that mass. So what's that mass going to be? 1.57 grams. How did I get that? I took 40.47 and subtracted 38.90 from it. And I get that answer. Now what did I do? I heated it up a third time. Now if I heat it up a third time, doesn't it make sense that if there's water in there, even more water is going to evaporate? And look, it does. And how do you know it did? Because your new mass is even lighter than what you ended up with last time. So water is being driven away. So what do we label this? A, B. This is B minus A, and we label this C. How in the world do you get this column again? This one right here? You take your dish and you subtract it out, and now we have just what's left. And if you do that, you end up with 1.47. And I'll go ahead and make this so it's red, I guess, to match the colors. So this is now 1.47 grams. What happened? It went from 1.6, I think it's 1.64 here, to 1.57. Why? Because you heated it a second time. Why did it get even lighter? Because you heated it a third time. Now, to really truly do this lab well, you should actually take it and heat it until this number stays the same. If it stays the same, that means there's no water left whatsoever. Okay? So, why do we do this? Well, we have the 2.49 grams of the hydrate. That's how much this hydrate without the dish weighed before we heated it. We have 1.47 grams left, right? Look, we started with 2.49 grams and we end up with 1.47. I don't care about all this other stuff right here. That's why we did this whole thing. We did all of this to get just this information. How about that? Okay? Why? This is what we started with, and that's what we end up with. So I start with 2.49 grams and end up with 1.47 grams. If I subtract them, what do you get? What do you get when you subtract the wet hydrate? We're going to call this hydrate before we heat it wet because it has water in it. And what happened to it? We had that evaporating dish. And what happened to the evaporating dish? The water evaporated out, didn't it? So if I subtract the two of them, I just get plain old water, don't I? Don't I get water? I think this is 1.02 grams. There you go. So that's how much water I had in my hydrate. So by subtracting my wet hydrate, quote unquote, and my dry hydrate from my wet hydrate, I get how much water I had in my compound. Okay, that's how much water is in the hydrated salt. Now, what are we going to do that? We're going to find the percent of water in the hydrated salt. What's percent? How do you get percent? I want to find how much water is in my hydrated salt. Well, how do you find percent? You do part. Oh, look at that. What part? The water, right? I want to find out how much water is in my salt. So don't you divide how much water is in, right? In means this right here. My salt, my hydrate. This is my whole. And why is this my whole? Because this salt is what I started out with before, and then I evaporated the water. And to get percent, you multiply that by 100. Let me show you. So I'm going to take this 1.02 grams of water. I'm going to take this 2.49 grams of hydrate. And I'm going to put the 1.02 grams of water on top. That's my part. That's right. What part of water is in my salt, right? Which is my whole. Right? It's the salt plus the water. That's why this goes at the bottom. And when I multiply them by 100, I get 40.96% water that's in my copper sulfate pentahydrate. That's how much water. That's a lot of water. 40.96%. Now, we should have heated it another time because that water, there might be still a little water in there. I don't know for sure. Okay? So now we need to figure out and compare. This is what we got, right? This is our experimental value right here. I don't know if that's true or not, right? We make all kinds of error when we do labs. We're not perfect. We spill stuff, we don't weigh it right. There might be still some water trapped in there. I didn't heat it till the mass stayed the same. So this is our experimental value, this 40.96%. So now what we need to do is we need to figure out how much water is actually in the compound. And how much is actually in the compound? Well, there's 5 waters, isn't there? In this whole compound. So there's 5 H2Os in this copper sulfate plus 5 waters stuck in it, right? Wasn't there 5 waters? And to get percent, we do multiply it by 100. So how do we do that? Well, we actually need to do the percent composition of water in copper sulfate. So how do we do that? We take copper and we look at the periodic table and sulfur and oxygen. And then there's one copper, right? Copper sulfate dot 5H2O. there's 1 copper and 1 sulfur and 4 oxygens, right? 4 of them times their masses. And that's 132.62 grams of copper sulfate. Plus, right, there's plus these 5 waters stuck in here. Now I'm just going to take the mass of water, which is 18.02, right? That's 1.01 and 1.01 and 16. I'm going to add them up and get 18.02. And there's 5 of them. So if I get the mass of these, then I have 90.1 grams of water. That's the mass of 5 waters. Now why am I doing this? Because I want to find the mass of the whole thing. So if I add just the copper sulfate, this part right here, and the water, and add them up together, I get the mass of my whole compound, 1 mole of it, right? So I get 222.72 grams of copper sulfate, .5H2O. Okay? And that's with rounding, and you get a little different number if you round it differently. So, to get my percent composition, I'm going to go ahead and take water, how much water, part, over the whole, times 100, and that's going to give me the percent water in copper sulfate for real. And that's 40.54% of water that's actually in the compound. Now let me see if I made another slide here. I don't know if I did. Okay, I did. All right. So you get that? Okay, you can pause it again if you don't understand that. Now what we need to do is something called percent error. Okay? So this percent error, what's percent error? Well, percent error is how far off are we? This is the true value. This is in theory what we're supposed to have. In theory what we're supposed to have. This is what we found in our experiment. This is what we observed. So in theory, what do we figure out? We figure out what's 40.45%, right? So this is 40.54%. 45. Okay, sorry. There you go. 45%. And this is 40.45%. Why am I putting these numbers here? Because that's my true value. That's what it should be if I have perfect lab results. We didn't get that though, did we? Okay. Oh, and let me go back here. So we can call it actual minus theory, observed minus true, experimental. What we got over what it should be, minus what it should be, over what it should be. Okay. So how do we do that? Well, our experimental was 40.96%. That's what we figured out. And our true is 40.45. Our true, or what it should have been, is 40.45. And we multiply that by 100. And when we do that, we come up with 1.26% error. That's how far off we were. That's a pretty good lab. We almost got all the water out, didn't we? If we'd heated it one more time and gotten that better value, had heated all the water out, and then another time just to make sure, we have gotten almost no error whatsoever. It's okay to have error. Why would there be error? Because we didn't heat it long enough. Okay? We heated it, but if you remember back here, I'll make sure there's not another slide back here. Oh, I've got these values right here. Actually, no, this is another lab, and I'll do this for an example. You can do it by yourself. But if you look for a second, right here, what happened? Sorry, going back. So if you look, what happened? It went from 1.64 to 1.57, and it got lighter. Right, I think I erased that. I'm not going to be able to get it back, but this is like 1.47 right here. Right? If you notice, it got lighter and lighter. I should have heated it another time. If it stayed 1.47, then it would have been okay. But it probably would have gotten lighter, and I know it would have gotten lighter because we were off by 1.6 something percent, which is wonderful. Okay? So that's how you write this up. All right? Now, you're going to go ahead and you're going to use this information. Okay? And you're going to go ahead and write up a lab by yourself. We'll talk about that a little bit later.